Algebra 3, Lesson 13. You'll notice that this is really different. If you have any of my other classes, which I don't, yeah, Michael does. So Michael knows that in geometry, I break it into like slide notes and I write up all these definitions and postulates and theorems and all these other things that you can kind of scroll through and look at and kind of catch all that information. And that's not happening here with this class, right? We spend most of our time just answering questions, correct? All right, your book has some good information, but I'm not going to go back through and necessarily line out everything that it covers. Okay, at this point, everything that you're looking at is review. I know that it's review because I know I've covered this before. Now, it might have been from geometry, it might have been from Algebra 2, but I'm kind of trusting that some of this information should still end up being reviewed for you. Lesson 13, the other part to this is that you'll notice that I do a whole bunch of writing things down in terms of stuff that's being said? No, I don't write down what this lesson covers, right? But is the audio picking it up? Okay, so if you go back and watch a video, what should you do? Listen to it, because is there a lot more information that's being given than what's being visually given? Yes, so you need to go back and listen, because lesson 13 is covering intersecting secants and tangents, products of chord segments, products of secant and tangent segments. That's covering a lot of information here, right? These Algebra 3 lessons cover a lot of information. All right, so it'd be really hard to kind of give you everything as the rundown. All right, the first thing that you're looking at, and it doesn't necessarily address this in order in the questions that we're looking at here today, but we'll try to cover it. Actually, the first thing that we look at is intersecting secants. Now, let's cover real quickly what a secant is. A secant is a line that goes through a circle. Okay, it intersects a circle at 2 points. Okay, so it could look like that, it could look like this, right? It might be a diameter, okay, but it's not a radius, right? It's going to go all the way through a circle. It's going to touch it at 2 points. Does that make sense? We're all covered there, okay? So what a secant is. So the first thing we want to talk about is if I have a circle and I have, let's see, a secant here and a secant here. One thing that you'll notice is that if there's a point of intersection there, that point of intersection is not always in the middle of the circle, is it? No. All right. Which means a couple of things. It means that my vertical angles, are vertical angles of intersecting lines congruent? Yes. Yes, they are. All right. So vertical angles, if you're not familiar with this, we've just covered it in geometry. Vertical angles are like this angle and this angle here. They're angles that are across from each other. They're not adjacent. Angles of intersecting lines that are not adjacent are vertical to each other. They're across from each other, which means that they're congruent. Okay? Now, typically speaking, if let's say we've got a circle and these are, that's a really poor job, but let's say that that's in the center, right? Let's say that that's a central angle being formed there, and this is 43 degrees. Then I know this is 43 degrees, and this is 43 degrees, and this is 43 degrees, if that's in the middle, right? That makes sense? Okay, the problem is that our example up here is not in the middle, okay? And you say, well, what's the problem? Well, the problem is if this is 43 degrees, and this is not in the middle, then this isn't a central angle, and that this is not 43 degrees. And this isn't necessarily 43 degrees, and this one over here on my far left is not necessarily 43 degrees. Okay? This might be 56 degrees. But I do know one thing for certain. I know that my vertical angles are still equal to each other. So if I got, okay, this is 43, and so that's got to be 43, and this has to be 56 because this one over here is 56. That doesn't work, okay? Because vertical angles are always what? Congruent. Okay, so do you see the problem with assuming that the that the inside angle is always going to be the same as its intercepted arc. That only works if it's in the center. Okay? All right. So what then happens? How can I get these two middle angles to be equal to each other? Let me make this a little bit smaller. All right. Let's say, for instance, that these outside angles are 43 and 56. Then this is what my two inside angles are. They are the average of those two. So how do I find the average of two numbers? 56 plus 43 divided by 2. That's going to be 99. Is that right? 99 divided by 2. 49.5. All right, which means both of these are 49.5 and 49.5. Okay, you'll notice on this one on the right, it's bigger than the outside angle, and this one over here is smaller than its outside angle, or its outside arc. Okay, they are the average. Okay, so the intersection here of two secants is going to be the average of the two outside intercepted arcs. Does that make sense? Okay, great. All right, let's look at this example that we're given here on the board. Let's see. All right, here I've got, looks like 80 and 60, right? I got 80 here and 60 here. What am I going to do with those two things? Add them up. What's 80 plus 60? 140. What's 140 divided by 2? X equals 70 degrees. All right, can we do that? All right, it's not one side is 60 and one side is 80. They have to be equal to each other. All right, because vertical angles are congruent. I think after having done this for a while, vertical angles come out to be this really, really important thing, but it's a really simple thing that it seems like students really struggle to remember, that vertical angles are congruent, and that applies all the time. Okay. Let's see. At 1 and 3, we still have secants, right? These are still lines that touch a circle at 2 points, but back here they come back to a common point. All right. So let's go to page. Actually, this is intersecting secants. Let's see. It looks like it's intersecting secants and tangents, but that's not. We don't have a tangent line there. So there's just intersecting secants. Okay, but they come back to a common point. Let's see. It looks like here, example like 13.2. Yeah, intersecting secants and tangents. So they're intersecting secants, but we're coming to the outside point. Let's put our information on here. Arc DE is 123 degrees. Arc BC is 77 degrees. Okay, we want to know what that guy right there is. All right. This is what you need to know. Okay, I've got this arc and that arc. So what we do, here's my formula, is make sure I got it right. Major arc minus minor arc, okay, divided by 2. Okay, that's how I'm going to find this outside arc. Okay, or outside angle. So we'll call it OA. Okay, major arc minus minor arc divided by 2 equals my outside angle. Okay, so I'm going to do 123 minus 77, divide that answer by 2. 123 minus 77 divided by 2. 123 minus 77 divided by 2. Okay, 23. Here's what you did. You didn't use any parentheses, and so what, okay, just so I can point out David on the video, this is David Eddy who made this mistake. All right, he plugged the whole thing in at one time. I'm fairly certain he did 123 minus 77 divided by 2. What do you think the calculator did first? 77 divided by 2, and then it took 123 minus that, right? We're going to do, because we always do the numerator, simplify the numerator, then divide. Okay, so we should be getting 23 degrees. Yeah. David says that he realized it, but I could tell by the look on his face, which you can't see, obviously, that he clearly did not get it. He's lying to all of us. All right. Now we can use that same principle to find any other portion, right? So down here on question number 3, I know the outside angle is 34, and I can't hardly read. We see 125 on my major arc. So what we're saying is we've got 125 minus x divided by 2 equals 34. Right? We've seen stuff like this whenever we were talking about, in like geometry class, we're talking about midpoints, right? Midpoints on a coordinate plane, right? If they give me an endpoint and a midpoint, I have to solve for the other endpoint, right? So we start with, we know the solution, but I have to find part of the problem. So what do I actually do here? What do I start with? Multiply by 2, okay? Because all we're doing is we're trying to solve for x. But you have to be able to set it up right. All right, so 125 minus x equals, what, 68? Okay, subtract 125. We're going to get negative x equals a negative number, right? What is it? Negative 57. So what do we know x equals? X equals a positive 57. What should I do? I mean, I know you're probably not going to do it, but what should you do? Check it. I should do 125 minus 57, divide that by 2, and see if I get 34, right? Okay, so the formula that you need to know here is that guy right there, okay? Do we have that down? All right. Let's see. Let's skip on down. It's the same slide? Oh my. Okay. Because we have several more pages worth of stuff here. And it doesn't give you any more than that, does it? Okay. Yeah. All right. Well, this is what I'm going to do for you then. I'm going to try to just, because I could go and look for these, but I'm not going to. I'm just going to try to write the question up here as it shows up on my stuff. All right. So I've got something that looks like this. This is x here. This is going to be 25 here. We've got A is this point. We've got B for this point. So I'm going to take a little bit more time because I'm actually having to write the question. C is out here. Let's see, we've got 10 for CD, and we've got 9 for CB, and we want to find out what X is, okay? All right. Let's see if I can find you a page number for this. This looks like it takes place a little closer to, this is products of secants and tangent segments. You'll find a similar example over on like page 103. And so this is a little tricky. All right, you take the outside segment and you multiply it by the sum of the segments. All right, so for instance, on this CD, and doesn't give me a name for this, but let's call it E for instance. All right, I'm going to take 10 times the sum of 10 and x. Okay? Okay? All right. And I'm going to set that equal to the same thing on the other segment. 9 times 9 plus 25. Okay? Do you follow me? Everybody. I want to see understanding show up on your face. Do you understand how those numbers got there and that I could duplicate this if I needed to? Okay. So on the left-hand side, I can distribute. So I'm going to get 100 plus 10x. Over here, I distribute. So I got 81 plus what? Yeah, you get 306 is the whole thing. So if you do the whole thing together, okay, you get 306. Okay, now we're just simply solving for x. So subtract 100, so you got 10x equals 206. So x is going to equal what, 20.6? Okay, and that's it. All right, that's all you've got to do. All right, but we do get some other odd-looking ones For instance, we could get a circle that looks where it's not two secants, but it's actually a tangent and a secant. Okay, something like that, where I've got x and 7 and 56. Okay, and ask you to solve for x. Okay, so here's how we do this when it's a chord or when it's a tangent, is that if you'll notice back here, right, 10 times 10 plus x. Well, I'm still taking 10 times 10, right? But if I just stop here, then there's no other thing to add to it, correct? All right, so in this case, it's just x times x plus nothing, okay? Because it's not secant, it's not going through it. There's no other addition to it. So you could almost look at it as x times x plus 0, all right? Equals what? No, 7 times 7 plus 56. All right, so you could do the 7 times 7 plus 56 as one thing. You could do the 7 plus 56 and multiply it by 7, and you should get like 441. So what we're going to wind up with, what do we get on the left-hand side? X squared. So we're getting x squared equals 441. How do I get just x? Square root both sides. So square root, okay? And I'm being told that x equals 21. And I'm seeing that that is true according to my paper as well. So does this make sense? The chord secant, okay? All right, we're about to make it more complicated. We always like that, don't we? All right, let's see if I can draw it, though. That's the kind of the hard part. Okay, I got something like this. Okay, I need to take it through here. Take this line. Oh, that looks, I actually did a darn good job. All right, we've got angle Y there. This is A. This is 25 degrees. We need to find this arc right here. This is point B. And we're told that this arc is 112 degrees. Okay, so we need to find x and y. Which one's the easier one of these two things to find? X, right? Tell me how to find x. We'll do x in red. Okay, that was Michael Pipes, y'all. Okay, gave me that. 112 minus x divided by 2 equals 25. Michael, why don't you continue on? Go ahead and solve out for x. Okay, you might not be able to hear him, but I'm following his instructions. Okay, so 112 minus x, he says, equals 50. Okay, let me scroll down here a little bit so I got some more room to work. Subtract 112, he says. Okay, so negative x equals negative 62. What does x equal? Divide by the negative, so dividing by negative 1, x equals 62 degrees. Okay, that looks good. All right, so he solved for x. Is anybody brave enough to try to see how could I go about y? Let's go ahead and let's put, maybe this will help you if you see 62 degrees. So we know that this is 112. We know that this is 62. What can I do? Make out the rest of the circle is something that I heard. All right, so how would I find the rest of the circle? Make sure that if you're going to do that, you do it like this, because if you don't use parentheses, you'll end up adding 62 back on. You need to subtract the sum of 112 and 62. Y is this angle. Okay? So what is 360 minus 112 plus 62? 182? 186 probably. 186. 186 degrees is from here to here. Okay? Does anybody remember how to find, if I have a chord and a tangent line, what do I do with that intercepted arc, Draven? Dude, divide it by 2. He's right. 186 divided by 2, what does y equal? 93 degrees. Okay, so there you actually had to remember something from a couple of lessons back to get the y. Okay? All right. Looks like, oh gosh, I still have more questions on here. Most of the stuff at this point, though, is repeat. For instance, let's just go through it real quick and make sure you know how to do it. Okay. For instance, if I got something like this now, oh, actually, this is a little different. This isn't asking about angles. We got 6 and 24 here. We got 18 and x here. Okay. So this is proportional. All right, what we're saying is that 18 times x is going to be equal to 24 times 6. Okay? I feel like we've done this, but maybe we haven't. Okay, so you take the product of the chord segments is equal to the product of the chord segments. Yes? Probably. No, we're talking about parallel lines cut by transversals in geometry this morning. All right, so really all I need to do is 24 times 6 divided by 18. So x equals 8. Good. All right, so you guys have got that. You got another one of those. So I think that, do we have this down? We understand how this works? It's different than the angles, right? Okay. So I'm going to skip this next question. I'm going to jump back to one similar to what we've done before, but I want to make sure that you guys can do it, given a little bit of a different scenario. If this is 12, this is 6, and this is x, how do I set that up? 12 times 12 plus 0, just so we understand, equals what? Okay, so we know on the left-hand side we're going to get what? 144. Okay, then I've got what? 36 plus 6x. Okay. Okay, so subtract 36 on each side. 108 equals 6x. So x equals 18. All right, we're going to do another one like this, but I think it's going to be a little harder than what these last couple of ones like this have been. All right, so it's still this. We still got this guy here. All right, here's 9, but here's x, and here's 24. Okay, let's see if that makes it any more complicated. All right, what do we start off with? Let's go ahead and kind of skip to the end of the left-hand side. What would it be? 81. 81 equals x times, okay, so we got 81 equals, that's where it makes it more complicated, right? Plus 24x. Okay. Now, what do I have to do? That's probably not how I'd go about it. I'd probably go ahead and subtract 81. Because what does that give me? Now I can factor this, right? Let's go ahead and see if we can just factor it instead of having to use the quadratic, because I do have 1 as a coefficient. I've got plus minus, so my sign should be plus minus. All right, I'm looking for things that multiply to be 81 but are going to add up to 24. We know 9 times 9, but that's not going to, that would end up canceling out. That'd be a sum difference. Not negative 27, but maybe positive 27. 27 and negative 3, which means x could be what? Or positive 3. Could it be negative 27 though? Why not? because it's a distance, so it has to be 3. Okay. All right, that's it. We've covered. I think we only skipped one question, but it was one I think that you guys could have done. So we're going to stop right there. Thank you guys for being patient, despite the fact that not all of these questions were on your notes.